Welcome back to the shop, everybody. My name's Gary, and today let's take a quick look at the controller upgrade I did on my newly acquired heat treat furnace. The reason I bought this furnace, again, I got this at auction, same time I got the little tool and cutter grinder and the electric chain hoist. But the reason I needed this is to do stress relief on the cast iron parts that I sell on the website. Many of you know I sell things like the cast iron camelback straight edges, and I need a way to stress relieve them after they're initially machined. They're stress relieved a bit once they cool down at the foundry, but once you do machining, you're going to release and induce stresses in it, and the cast iron is going to be somewhat flexible until it's stress relieved again. It can twist and bow and stuff like that as you release and induce the stresses of machining into it. So I needed a way to stress relieve them again before they're shipped out. Right now the only thing you can get are raw castings, so if you have a large enough shaper or planer, you can purchase the raw casting off the website, do your own machining and stress relieving, and be done with it. I'm hoping to do a complete initial machining on the planer once I've got the planer running, and stress relieve in the furnace before they're shipped out. Offer that as an add-on option. So that's why we need the heat treat furnace. So let's take a quick look at what I got with the furnace initially and where we went with the control after that. I've got the heat treat furnace moved over in the location where I'm going to set it up. May not be the final location. I'm not really thrilled about where it's at. It's right next to the planer over here, but this was the best location presently. I may do some rearranging in the shop later on, but fixing to get started on ripping out all of the old controls here on the furnace. It's got a fancy looking control panel on the front, but Stan Zinkosky over at Bar Z helped me research, and we determined it's basically just an on-off type control, and it's using old mercury switches. And Stan helped me source a replacement control unit from Novus, the same unit that's used on his Hotshot 360 tabletop heat treat ovens, and also helped me with the correct solid state relays on his unit. The Hotshot 360 is single phase, so it only uses one solid state relay. Since this is a 3-phase furnace, I had to get 3, so I've got to get all this stuff out of the way so I can get the new stuff put in. So let's take a clip now showing the aftermath of ripping out all of the old control parts out of this control box here. Got the old control taken out, and got the new Novus control here, and I 3D printed a new insert to cover up the big hole in the front, since the old control was quite a bit larger, as you can see, in comparison to the smaller Novus. So I 3D printed with the dimensions given in the Novus information brochure, and it's just a press fit now, but I'm going to more permanently attach it with the plastic binders that come with it. These go above and below, and they snug up. This plastic ring collapses against the back of the panel here, so it'll snug it up good. But I'm going to have to get all my wiring done before I'm ready to do that, so I need access to the back side of the control there. And so that's where I'm at the moment. Getting it cleaned up, getting ready to put the solid state relays in there, get them mounted on that back. So as you saw, I've got it ready for the new control and the wiring to get started on this. Let's take a quick look at the solid state relays and how I was going to mount those into the box. I've got the solid state relays here. I've got 3 of them for the 3-phase furnace. and I've salvaged some heat sinks off of some computer components. Didn't have 3 of the same, but I've marked for drilling clearance holes through these so that I can mount the solid state relays, because they have the possibility of getting pretty hot. These are rated for up to 50 amps. The furnace draws 23 amps, but they could still get pretty hot. So planning to mount them on there with some 1032 bolts with some clearance holes through there. And I've got some DIN rail, and I've got some 1/8 inch aluminum, and that'll tuck nicely with a little bit of clearance on the back side. So I'm going to cut off a piece of the DIN rail and a piece of this 1/8 thick aluminum, and I'm going to drill and tap for the 1032 bolt for the heat sink and the solid state relay to bolt onto there. And I've got the wiring connectors for the DIN rail to hopefully do a little neat job on it. Hope it comes out neat anyway. That's the plan. So at this point I've gotten everything wired in, ready to test the unit out. So we're going to go through and do a quick little heat up just to see that the solid state relay is energized, that the heating elements all come on, and we start bringing the furnace up to temperature. It's working. I can hear the buzzing, and the phase perfect over there, you could tell that it kicked into a little bit higher gear once the juice started flowing over to the furnace over here. So now that our little test heat was done, Stan gave me a test profile to run on the unit, and it ran for a couple of hours. So let's take a quick look at that and see what that entailed. Running a test profile right now, and it's basically just exercising the controller and the solid state relays. It's just gradually ramping up 1 or 2 degrees per minute, and it's going to 1500 degrees, and it'll hold that for an hour. But the oven could go a lot faster, heat up a lot quicker. This is just an exercise, so that's what's going on at the moment. So as the furnace approached 1500 degrees in that test profile, I took out my temperature sensing gun, and I wanted to test and see what the difference in temperature inside and outside the cabinet was. So inside we were approaching 1500 degrees. Let's take a photo and show what the heat gun shows the outside, and I checked it all around the outside of the cabinet, so it's pretty well insulated. Let's see what the heat gun showed on it. So that's a differential of 10 to 1 basically, the difference between the inside temperature and outside. So it really doesn't get very warm on the outside. There's a little over 3 inches of insulating fabric inside. To give you an idea of just how well insulated this unit is, I took it up to 1550 degrees, took it 50 degrees beyond the 1500. After I was through testing for the day, I cut power to it, pulled the control out. No more juice to the unit. It was at 1550 degrees. Came back 12 hours later. The inside of the oven was still 420 degrees. So it retains the heat for a long time if you leave the door closed on it. So I was kind of surprised it held the heat that long, but it does seem to be very well insulated. So there you have it. If I can do this upgrade, anybody can do this upgrade. This was done remotely through Facebook Messenger with Stan Zinkosky. I'm in Texas, he's in California. I did this just off and on over 2 days' time, and it was super easy and simple to do. So if you want your own heat treat furnace, check with Stan about the Hotshot 360. Get on the waiting list. They're extremely popular right now. And if you come across and want to upgrade an existing heat treat furnace, very easy to do. Hopefully I'm giving you a little motivation and excitement to get out there and get your own heat treat furnace. Get excited about the PID controls that are available now. Control, which is like cruise control with programmability for your heat treat oven or furnace. Well, thanks for coming by the shop today and taking a look at this upgrade on the furnace. If you haven't subscribed to my channel, please do so. Hit the bell at the bottom so you're notified of new videos. Hit the thumbs up for like. Please share it everywhere so other people are aware. Again, thanks for watching, and I'll catch y'all next time.